Hello everyone, my name is Atul Kumar Singh. Today we are going to solve LeetCode problem number 1 that and its title is to sum. So what the problem is saying, given an array of integer nums and an integer target, return the indices of two numbers such that they add up to the target. So what we have to do, return the indices of the numbers such that they add up to the target. You may assume that input would have exactly one solution, or you may not use the same element twice. So in an array nums containing the element 2, 7, 11, 5, we have to add up two numbers such that the sum is equal to the target. So if we add 2 or 7, the sum is 9, which is equal to the target. If we add 7 and 11, the sum is 19, so the sum is 18, which is not equal to target. And simply add any two numbers in the nums array such that the resulting sum is equal to the target. So, and we have to return the index of that element with sum is computing to the target elements, which with sum is equal to the target. So, what can be the one brute force intuition? We can simply uh, assume a pointer here and a pointer just next to the element. We will take a static pointer here and iterate and the second pointer here, and we will iterate through each element for and compute the sum, that is 2 plus 7, that is 9. Then we'll move the second pointer here, then compare 2 plus 7 9, so we've got our target. If not, then 2 plus 11, that is 13, which is not equal to target. Then simply this is done, then we will move back to our next pointer, and the next pointer just ahead of the previous pointer. Then we will calculate the sum, then compare with the target. So this is a brute force approach, simple approach, but its time complexity is nearly big of n square. As we are iterating for each element, you are iterating nearly to the whole loop. So which is not ideal. So to solve this, we can use a unordered map. So what can be an intuition? The target is 9. That is 2 plus 7 is 9. For 2, we have to find 7. Means 9 minus 2 is 7. So in unordered map, we can check if 7 exists in the map. If 7 exists in the map, means the pair of 2 is going with 7. So we can simply return the index as 0 and 1. So this is our logic. That means target is 9. So we can do 9 minus 2, that is 7. So we have to look for the 7. Then for 7, we will do 9 minus 7, that is 2. So we have to look for 2. So in this way we will look and check uh, the two numbers which are resulting the target sum as 9 or not. So what we will do, we will simply create an unordered map. Un Unordered map having key as integer and also value as integer. Here key will be your number and value will be your index. Then we will simply run a loop equal to 0 and I is less than nums dot size, and I plus plus. We have to check what element we have to find. So currently we are at 2, we have to find 7. That is, we have need of target minus nums of I. Target is our 9 and nums of I is our 2. So we are looking for the 7. So complexity, so we will check in condition map dot find this need to find for this need. If this value exists, we can simply return the index. If it's not equal to the map dot, if it's not equal to map dot in means we have successfully find that pair. Now we can simply return this is our answer. Return of the need. So this will give the index and I the current users. This is our pair. If you have not found, then simply add it in the map. Map the keys are nums of I. Nums of I means the value is our key and the index is our value. So this condition will give our answer, but we have to return a vector. So at last, if you're not getting anything, we'll simply return a empty vector. So let's check it's working or not. So we have got a error here. Let's check. We have not given semicolon here. So let's skip semicolon and compile and check all the three test cases. So all the three test cases are passed. Now let's submit the code and check for all the test cases. So we can see it has passed all the test cases. So you can simply say what is the time and space complexity. So we are running a loop for nearly big of we are running a loop till all the elements. So time complexity is big of n, and we have used a map. So the space complexity is also big of n. So time and complex space complexity is